Hello. Let's do a couple of use substitution problems together. I'm still working on indefinite integration problems with use substitution, and then I'll work on some definite integration problems with use substitution in a little bit. Okay, so let's work on this one first right here. I've got the integral of x squared plus 2/3 x times e to the x cubed plus x squared plus 1 dx. Quite the function, and a great candidate for use substitution. Go ahead and pause for a second and take a look and poke around and see if you can figure out what you think you should be, and then I'll tell you what I think you should be. So pause the video for just a second. Okay, did you pause it and unpause it? Cool. So I think you should be the thing that's inside, the inside function in general. That's where I start, at least. And I see something inside of an x and then polynomial outside. And so I'm going to try to let you be that piece right there. So I'm going to let you equal x cubed plus x squared plus 1. So I need to hopefully take up the rest of this. We'll see what happens. Du is equal to, I'm going to take the derivative of this. I'm going to get 3x squared plus 2x plus 0 times dx. Those parentheses do matter. Dx is against that whole thing. Okay. So I write down what du was. I took what du is, and now I want to find du in the remaining expression, and hopefully it takes up the rest of the x's. So I don't see 3x squared plus 2x. I see x squared plus 2/3 of x, and I need to get some 3's in there. Rather than try to cram some 3's in here, I'm going to go ahead and factor out a 3 from this expression, and we'll see that du is equal to 3 times x squared plus 2/3 of x dx. Okay. Okay, cool. Well, I have x squared plus 2/3 of x dx. And so in order to get a 3 right here, all I have to do is multiply by 3. But you can't just multiply by 3. We've also got to multiply it by a 1/3 in order to make sure that we're keeping the function the same. So now I have this piece right here. And I really do like circling them when I do these problems because they help me make sure that I've taken up the whole function. It's kind of a visual cue to me that I'm on the right track, hopefully. So, visually checking, I can see that all the x's are taken up. All I'm left over with are numbers. And so this is equal to 1/3 of the integral of e to the u du. And after we've done substitution, we should be entirely in terms of u. And then hopefully our function is simple. So now, can I integrate this function? The answer is absolutely yes. I remember that the integral of e to the x dx is e to the x, or the integral of e to the u du is e to the u. So this is e to the u with a factor of 1/3 on it plus c. Now I'm going to go ahead and finish the problem off by unsubstituting, and I'm going to get 1/3 of e to the x cubed plus x squared plus 1 times, nope, well, I started writing my dx there. I just really wanted to write dx, but that's okay. Okay, plus c. Whew, okay. And we're done. If we were doing definite integration, then we would do evaluation and subtraction for the bounds. But again, I'm leaving that for other videos. Okay. You ready to try another problem? I am. I really like this problem too. Okay, so we want to try to let u be something, and we're going to hopefully find we're going to find the derivative of that thing inside of our function. So I see like x and it's in the bottom. And so I think I'm tempted to let u be the natural log of x. And the reason is if I just have u be x, then du is dx, and I don't win. So we've got to do something more complicated than letting u be x. If u is 1 over x, then I would have like 1 over x squared for du, and I don't have that. But I totally see this natural log right here. And the derivative of natural log is 1 over x. So I'm going to let that be u. And so u is equal to natural log of x, which means that du is equal to 1 over x dx. I think I'm on the right track. So here's 1 over x dx. That's du. And nothing that has an x in it didn't get circled. And I think that means that we're ready to go ahead and do the substitution. So this is equal to the integral of 4 over u times du. Yeah. Oh, this is such a cool problem. I love this one. And I know how to integrate this. The integral of 1 over x dx is natural log of absolute value of x. So this is the integral of 4 over u du. So this is 4 times the natural log of the absolute value of u plus some constant c. And we're not quite done because we're still in terms of u. So this is 4 times the natural log of the absolute value of the natural log of x plus some constant c. Oh, that's so cool. Wow. Natural log of natural log. Oh, wow. Integration is so cool. Okay. So hopefully you find those two things instructive. Keep being willing to try letting you be things and see what happens. Yeah, we'll see you again for the next video. Thank you. Bye.